Okay, so this module cover 8 chapter: chemical bonding, gas, liquid, solid, intermolecular forces, solution, acid and base, chemical equilibrium, electrochemical, and today we do organic chemistry. We'll be focusing on the hydrocarbon, right? Hydrocarbon. Okay. And I forgot to mention your assignment when I do mention it due. Assignment. I mentioned the due date. Okay. I give you on 26 over 9. The next day of your test too. 5 p.m. is Friday. Okay. So chapter 8, we talk about organic chemistry. We are focusing on hydrocarbon. And then in the test or final exam, you need to know how to name the structure. And I give you one formula. I say C2H6 Cl. You need to tell me what is that name in the international standard. Okay. All right. So why do we study this chapter? Is because our world is full of smell, right? Full of smell, perfume, and all these things. They will give us some sense of smell, right? So how do we smell? It's because our nose, sensory, all this lah. So you can smell rose, cinnamon, and so on. Okay. So these are the senses, chemistry, that you can find in the encyclopedia or on a website. So different chemical, it will give you some smell accordingly, right? So some smell like rotted fish. Some is if you see the bone one means very dangerous, poisonous, and so on. Some smell coconut, some smell like orange, and so on. Right? So this one you read, you read. So what are the organic compound? What are the carbon compound? So organic compound, it means it's come from live things. It come from a cell and so on. Carbon compound is what we're going for focusing on. The simplest one is CO2, carbon dioxide. Carbon dioxide, methane, benzene, and ethanol. These are the three famous member in chapter 7. Right? Okay, so this one you go home and watch lah. Huh? So this is basically predict water. So that time people believe in organic compound, but we found that ammonia is inorganic. Ammonia is inorganic. Right? So it just basically means that the ammonium can made by people, means it's not organic, right? So this one you read, there's some history about ammonia. So someone discovered it, it is not organic. This is the summarize of all the slides. Okay. 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 So what are the differences between organic and inorganic? Organic is on the left hand side. Inorganic is what you human made on the right hand side. Right? So table salt is you made it. CO2 is through combustion. HCl you mix through the chemical process, then you generate acid. However, on the left hand side is a life form. DNA, sugar, glucose, all from photosynthesis, and somehow the cell creates some energy. So methane, ethanol, this one you can find in the volcano, those high temperature area, right? Okay. Okay. Now, as you can, as you already learned in your fundamental physics in your SPM, you learn about CH, which is hydrocarbon. So carbon with 4 equivalent carbon can form 4 covalent bond. This one you learn in your chapter 1, right? So if you're given 1C carbon means it's a group number 4, so you have 4 equivalent electrovalence. So to meet the octet rules, means you need to have 8 electron outside. So you need to grab hydrogen, 4 hydrogen, group them together to form stable state. In this case is hydrocarbon. So carbon and with 4 hydrogen. Same with another element, for example, oxygen. We will form single bond and double bond. This one focus on carbon, right? So all these things you already learned in your chapter 1, right? So now this chapter you only focus on carbon, hydrogen, and some element, C and H. Okay. So later on let's say I give you this structure. You have to know that from the table, you have to know that this is called propane. So there's a way of calling this one. I'll teach you how. Okay. So these are the example of hydrocarbon. Okay, chlorhexane, isobutanate, and so on. Okay. So these are the refresher for chapter 1. Right? We have seen what is tetrahedrogeometry and so on. Right? This one covering chapter 2 on the shape of molecule and so on. Okay, triple bond and so on. Right? So by now you should be able to understand why this one is linear geometry. It's because it's balanced, no electron valence, and the bonding is share symmetrical. Okay. Okay. So this is a very important diagram, which is summarize chapter 7. So we start with hydrocarbon. We start with C and H. The combination of carbon and hydrogen, it will give you different family of hydrocarbon. So hydrocarbon, you will break into saturated and unsaturated. Saturated and unsaturated. So this will be one question, I think 1 or 2 questions in your lab report. You need to answer why is it saturated, what is unsaturated. Okay, so of course in this lecture we also covered some. So saturated and unsaturated. So under saturated, we have only one family, which is called alkane, Alkanes, alkane, with the general formula CnH2n plus 2. Okay, so alkane, CnH2n plus 2. No choice, you have to remember all the general equation of the family. For example, once you calculate all the general formula already, at the end, you need to identify whether it's alkanes or CnH2n, or alkylanes, CnH2n minus 2, and aromatic hydrocarbon. Okay? So if the mathematic formula that you cannot form either these 3 formula, you cannot group under these 3 formula, combination between C and H, C and H, C and H, it will fall under aromatic hydrocarbon, where you see, or in general, you'll see ring like benzene, ring structure. Yeah, so this one summarized chapter 7. Later I'll show you how to name the first family, saturated and unsaturated. We will name 3 families. Yeah. So the detailed one you read from the slides. Okay. So hydrocarbon, basically, these are the example of the hydrocarbon. So they are hydrocarbon means they only form by carbon and hydrogen, C and H. Right. The rest example you read from the slides. Okay. So based on the molecular formula. Determine whether the non-cyclical hydrocarbons are alkynes, alkalides, and alkanes. So this one is by using the tree formula, which is this one. Okay, by using this tree formula. This tree formula. CnH2n plus 2. If you're able to calculate using CnH2n plus 2, mean is for other alkane. If you're able to see alkane CnH2n, then for the alkanes and alkylanes. So is for under here. So it's just a mathematics calculation. Okay. All right. So first example, C7H14. So this here you can see N is 7. 14 is what? 2N. So you have N and 2N. N and 2N is 4 under. N and 2N is 4 under this one. Yeah. So this is basically mathematics. Number B, you see C10, H22. This is N. How to get 22? 2 multiply N, 20 plus 2. So 2N plus 2. Right? So 2N plus 2 is what? It's the first one, alkyne. Cn, H2N plus 2 is this one. Okay? So this one, C3H4, 3 is N. How to get 4? You must N plus 1. Right? N plus 1, or you see whether got or not. So if do not have N plus 1, so you can have N H 2N minus 2. So you calculate. So if this is 2N, so 6 minus 2 get 4. So it's 4 under alkane. Now this is how you identify whether the element is fall under which family. These are the first formula for today. You must remember, it won't be given, and it's a free mark question. Either you know or you do not know. Yeah. So this general formula will not give in the test or final exam. You are expected to remember. Yeah. These three formula for today. Okay. All right. So this one I already explained. Okay. So by this one, you should able to do, right? C6H12 is what? CN, H is what? 2N. This one, C814, 2N minus 2. This one, 512 is 2N plus 2. Yeah, so by that you can identify which one of it. Yeah. Remember to sign the attendance list. Okay, this one also same. Same. Yeah, remember this three formula is important. It's important. I write here. Okay. Cn H2N plus 2. Alkanes Cn H2N. Alkene. Alkenes. Okay, these three. So the rest, if you're interested to know what is non-cylindrical compound, it means that non-cyclical means CH, and then sometimes you can one corner of the H, you will see a ring structure like this. If you see ring, mean it's a cyclical compound. Usually when you see this very weird shape one, is aromatic compound, the last category. If you see something that outside C and H, and then some very weird shape, normally they are aromatic compound. Okay, so these are the general summaries of what is chapter 7 about. The rest is just naming of the compound by using table. Okay. Okay. All right. Now, under saturated hydrocarbon, the only one family only, with the CnH2n plus 2 alkanes, right? They are saturated carbon. So why they are called saturated? Because they are saturated with hydrogen. Means they have a loss of hydrogen. If you compare the second one, this side CnH2n is less than the saturated carbon. And you see alkanes also less than the saturated carbon. Right? So saturated means they have loss of hydrogen compared to another family. The total hydrogen that they have is more than the rest. Yeah, remember the three formula? CnH2n plus 2, CnH2n, and CnH2n minus 2. Okay, so this definition is important also. So sometimes the question will ask you, give definition of a saturated carbon, or how do you know it is a identified saturated carbon? If you see the question identified, means you need to give reason first, need to give definition first. What is saturated carbon? Then identify. Don't straight away name the answer. You need to explain why first. Yeah. So this is how you answer for chemistry. So, okay. So the simplest one, the simplest alkane is what? N is not zero. If N0 means no carbon. No carbon is not hydrocarbon. You must have C and H. So N, the minimum number for N is 1. So 2, 1 plus 2, so is 1, 4. So the simplest one is called methane. Methane. So CH4, you should be able to draw the device structure with the single bonding. Okay. In the exam, we won't ask you to draw space filling model. This one, when you go into degree, during simulation, then yes, you will see this one. Okay. Okay. Rest you read, Rest you read. This one already covered in chapter 1 already. Chapter 1, chapter 2. Okay. Okay, so methane cycle, this is additional information, how methane works in the daily life. Okay, start from soil, then some fermentation, it will raise, and then through either main activity or unmanned activities through burning, so you will form CH4. Yeah. Okay. Second type, CnH2n plus 2 called alkane. So what is the next simplest after methane? N is 2. N2, H6. So this one, N replaced by 2. 2 multiply 2 get 4 plus 2 get 6. So 2 C2H6. Okay, so it called ethane. So ethane got 2 carbon and it share with 6 hydrogen. Yeah, and hydrogen only have 1 orbit only. Still back to your periodic table. Hydrogen is on the top of the periodic table. Group 1, with its mean hydrogen only have 1 electron outside the orbit. Maximum is to share duet rules. Means maximum only you share with 1 and make the 2 electron valence outside for the first orbit. For the first orbit, first orbit. Only for the first orbit only, you only can put in 2 electron. Second orbit onwards, you can more than minimum 8, and then there's a formula to form that, right? Okay, so the use of ethane, this one you read lah, you read. Okay, so these are the process, how the process go, and usually you use heat to break the bonding, and then some cycle, then at the end you get the products. Okay, so this is also additional info for you guys. Okay, if you study chemical engineering, then you will need to design the factory floor for the process. Okay. Okay, synthesis is how you do it. So this one also information for you to read. Okay. Information for you to read. This one you read. Okay. So the third one is called propane, which is N equal to 3 or equal to 3. So H will be 8. C3H8 is called propane, which is the liquid petroleum that you use in your daily life lah. Okay. So the structure will look like this, right? CCC, 3 carbon, and then surrounded by 8 hydrogen. Okay. Okay, so question for chapter 8, usually I will just give you the molecular structure, molecular formula. I ask you to draw the structural formula. And then after that, I ask you to name the structure. I ask you to name this structure. What does this structure name? Right? So this one will use all the tables that I attach in the tutorial handouts. You need to refer to all those tables. Yeah? Right. So the rest you read, The rest you read. Okay, so sometimes you will see in some textbook, they will use condensed structural. Okay, in the test, I won't ask you to write in condensed structures. I will ask you to draw structural formula and name the structural formula. Condensed means you remove the bonding. You remove the bonding and you focus on carbon. How you write, if you compare structural formula and the condensed structure, you focus on one set of the carbon. Means if you break this one into 3 sets, C and 3 hydrogen, middle one is CHH, and the far right is C and 3H. So this is how you break the structure. Okay, and the way you write must count from the left to right. You must start from left to right. So the far carbon have 3 hydrogen, then the middle carbon have 2 hydrogen, and the far right have 3 hydrogen. That's why you see the formula is CH3, CH2, CH3. And it's not CH2, CH3, CH3. No, you must follow the sequence of the structural formula. This is called condensed. Condensed structure means you remove the bonding. And remove the single line in the structural formula. Okay. Yeah, so this is already explained how they see it. So the next one is called butane, which is N equal to 4 and H equal to 10, which is in the canister of gas that you use for your camping stove and so all this. Okay, so it's called CH4, and you should know how to draw this one already. Right? So four carbon and then surrounded by 10 hydrogen. Okay, are you able to write the condensed formula? You're able to write, means you focus on the carbon and start from the left hand side. You focus on the first C. You cut You cut the first C, you will see 3H. So condensed formula for butane will be CH3, then focus on second carbon, which is H2, and the third one is H2. The fourth one is H3, like this. This is condensed formula. You count from the left to right. Okay. So if we have a straight chain without branching, the one we have seen is called normal alkane or N-alkane. So, like for example, this one, right? So, for example, the butane just now. CH3, CH2, CH2, CH3. And you fall under N alkyne. With this, you can write as CH3 bracket CH2, and in this case is 2. The small m for butane is 2. Okay, it's called N structure. So this is the number of the middle CHH. Yeah. So they are called N alkyne. Next one is N equal to 5, they call pentane and so on. Okay. Okay, so as you can see here, this is a boiling point. So we have gone through methane, ethane, propane, and so on. So as the number of carbon increase and alkyne, so does the boiling point. So if you have more and more carbon inside the structure, means they have a longer chain. You have a longer chain means you have C, 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 C. Have a longer chain means you have a higher boiling point. You need more heat to break the bonding. Yeah. Just remember that lah. This one, the summarize means in the test, you look at, there will be some question ask you, arrange the element, the hydrocarbon based on the boiling point. So it means you need to know how to draw the structure formula. And from the structure, you count how many carbon it have. Right? So you draw methane, ethane, propane, butane, pentane, hexane, and then you arrange from the lowest boiling point to highest. So methane, ethane, and so on. Okay. So these are the table that also I think I give you, right? So in your right. So there are many of these structures, condensed structures, right? Condensed and structural formula. Yeah. So I don't expect you to remember, but at the end of the lecture, you should be able to name that one based on the molecular formula. Or I give you condensed formula, you should be able to name it straight away. Like for example, number 1, I give you CH4. You should be able to draw the structural formula. From here, you should be able to name the structure. Okay. You don't need to memorize because the table, this table won't be given, but how you name it, the table later on, I'll give you, right? So these are the example. The use of hydrocarbon, also, you just have a look, it's just for your info, right? Okay, so we have done. So write the structural and condensed structures formula for N-octet C8H8. So this one, you should be able to draw lah. Okay. So again, draw the backbone first. When you draw the structure for hydrocarbon, you always start with carbon. So now you see the octane got C8, so got 8 carbon. You write the 8C first. C 8, and then you join the C with one line first. Then you know that C got 4 dot, right? C is group number 4. You got 4 dot. Got C with C already. It means you have joined one carbon already, right? So you count 18. First, you draw the carbon first. Then you add hydrogen to all the carbon with 4 bond. Means you know that each one of these will have this. Right? Why is 3H? Because this side you already combined with another carbon electron. Right? So here is H, H, H. Any question for the structural? Should be easy, huh? First, you start with carbon. You join it with a single line. And then next, you write the H around the carbon chain. And then you add a single dash like that. Okay. Then he asks you to write the condensed structurals. Mean you count from the left to right. You break carbon and you write lah. So this one is C. You write CH3, and this one repeated. CH, you can bracket, and then there's a power of sub M there. Because it repeated so many times, you don't need to write. Of course, if you want to write CH also can. But more simpler way is you use bracket and then sub power it. Okay, it'll be like this lah. So this is the very traditional way, but professional way, you will bracket the CH2 with the power of sub power of 1, 2, 3, 4, 5, 6. Okay. Yeah. Okay. Isomer, you have seen this one before, right? Okay. Isomer is they have branch. Isomer, they have branch. So simplest branch alkyne is isobutane. So isobutane, CH10. Mean that this one is not continuous chain. The C somehow join, branch out. Okay, what is branch? What is not branch? Huh? C, H, C. Let's say I draw the 3C. Huh? This is non-branch, is chain. If it's branch, no, I should put 4. This is branch. Okay. Means if it's break, if there is something come out from the middle member or from the body, usually it won't go to the end, right? It will go into middle. Yeah. Okay, so these are the example of the isomer, not isomer, ethane, pentane, methane, and so on. This one is to this one you just have a for info lah. This one for info. Okay, so isobutane and butane, they are isomer. Isomer means they have the same molecular formula but different structure. This is also one of the definition that we are looking for. So it asks you identify isomer. So if you see identify, you need to explain what is the meaning of isomer. So isomer is molecule with the same molecular formula, means CnH2n something. But if you draw into the structural model, then you'll be different. For example, N-butane, we have 4C and 10H. However, for isobutanate, because it's branch out, it's become a 2 different element already, but they are isomer. Yeah. So these are a few examples of isomer. Okay. This one you go home have a look lah. Okay. Okay. So in exam, you need to write the structure in the IUPAC name, which is international something something something. Right. Okay, let's read. Okay. So draw the 5 isomer of hexane. Okay. So Hexane is got 5, got 1, 2, 3, 4, 5, 6. Hex means 6. At the moment, maybe you are confused. Hey, how do I know how many carbon? Later, I'll refer you to one table. You will see. So you draw the carbon bond first. After that, you draw the hydrogen. So you arrange by the possibility of branching of the carbon branching or carbon molecule. Means this one got 1, 2, 1, 2, 1, 2, 3, 4, 5, right? 5 bonding, single bond. You can break one, you can take one, and then you like Lego, you want to combine with any C in the middle. Like for example, there are 4 possibilities of arranging the carbon. This is called branching. Okay, the first one on the top is called one branching. This one on the right is called two branch. It's called two branch. Right? This is also called two branch. Split two branch. Right? So later we have naming. I will teach you how to name the thing. This one also branching. Understand? This one like playing Lego. You break one carbon, and then you mount at any place you want. Okay, you play with the combination. Yeah, so this is how you do it. Okay, so if you seen there's a same combination, for example, the one on the top and bottom. If you like, you see it as a Lego bricks. The one on the top, this one, and the bottom one, actually, if you flip them around, they're actually the same thing. If you play with the Lego, you flip them around, you turn 360 degrees. The top one and the bottom one, they are identical. So you only have one combination. Yeah. So this one I go very fast. If you understand, I go very fast. The rest is just filling up the hydrogen. Yeah. Just remember, carbon only have 4 sparking lot. So those already have line, you cannot fill in the hydrogen anymore. Yeah. This one you go home and see the slides. Okay. So far we are talking about isomer. Okay. So we start to do for what you'll be asked in your test 2 and final exam. So we will use guidelines as per IUPAC, which is International Union of Pure and Applied Chemistry, which is international standard, IUPAC. There are a few steps. First, you look at the table, red table, right? In your tutorial slide there, there's a table, red table. So rules 1, go focus on carbon first. You calculate how many carbon first. Like CN, you calculate the CN first. How many carbon? So if N is 1, is called met. You use the first met. You start with met. Okay? You start with met. After the met, ANE. ANE, how you name it ANE is by using the general formula of the hydrocarbon just now. CnH2n or CnH2 minus 2 and so on. Use that formula to identify whether it is what kind of family. Okay, first step, count the carbon first by reading the formula, chemical formula. Okay, so and then you go to this table. This table will be given. Don't worry. First, count the longest carbon atoms. Second, like for example, okay. So how you count? How you count? We numbered the carbon chain starting from the right-hand side so that the number of the group will be 1 and not 3. I give you an example here. So here, you count by You count by the right hand side. Okay, so this one, okay, this one later. We look at rules number 1 first. Rule number 1 means you look at carbon. So 1, 2, 3. So 3 is what? Prop. 3 is prop. 1, 2, 3, 4. 4 is butt. You start with butt first. Then the rest we will continue with other rules. First, you count the carbon first. Second, identify functional groups. Okay, what are the functional groups? Second, you look at functional group with this another table. The second table, second red table, with you look at the functional group, this one. With this alkane, and so on, ether, and so on. So you look at the functional group with this one. Okay, you look at you draw the chemical structure, and then look at what does it have. If it's double bond, carbon-carbon, it's called alkylate. If it's triple bond, carbon is called alkylene. OH is hydroxyl. And you have O and O, and there's a continuous bonding, it's called ether. You see C, O, and H is called carboxylic or aldehyde. Right? So you use the prefix according to this table. Yeah, first look at carbon. Second, look at the functional group. This is a second table you look at. Okay. Yeah. Okay, all the general formula like this. This is a general formula. You are given a general formula. You read the general formula from this general formula. Okay, you count like mathematics whether in which family. So let's say it meets CN, H2N, you use ethane. Either it's propane, hexane, and so on. Okay. This the long table, long table. Okay, so and so on, huh? So, like for example, how do you know that this is butane tonic acid? You look at CCC, 4C is butt, 4C is butt. Then you look at the functional group. H doesn't count. Functional group means you look at the C and then combine with what? So COOH is this one. So it's a carboxylic, and it's you use suffix in IUPAC name is arenoic acid. So you put this arenoic acid in after the butt. Combine this one with the butt. So you call butanonic acid. Like for example, another one. How do we know this is propanone? You calculate the carbon with this 3 is prop. And then look at functional group with this one. C, and then you have a O. CO, and then there's a carbon beside. RR. Repeat. This is called repeat identity or repeat structure. So this one, 3 is prop, and then you go to the functional group table. Remember to read the suffix AUPC name and not the functional group. Read from here. This one. So this one, prop with the ANONE. Combine become propanone. Okay. So we repeat the same one. Okay. So in the functional group, after functional group, identify side chain or the branch. First, look at the carbon main chain first. Main chain first. Second, you look at the carbon. Is there any like branch out with all those functional group? Next, you look at all the rule number 3 is only focused on halogen and amide, which is fluorine, chlorine, bromide, iodine, NH2. If you see F, Cl, Br, I, and H2, then you refer to the third table, rules 3. And you remember to read from prefix in IUPAC name. Yeah? So I'll show you how. So these are the general way of naming the thing. So like Chinese name, we have surname and family, surname and family name, right? So prefix is carbon. It's like your surname. Like myself, I'm Ang. So prefix is my Ang. So you write Ang here. So number of carbon in the long stem and then suffix. So this one, sorry, this is position. Position, we will count later. Prefix is your surname. Suffix is your family name. This is number, son number 1, number 2, number 3, and so on. Okay. So this is a prefix. Okay, prefix with its number of carbon, 1, 2, 3, under 10. I won't ask you more than 8 in the exam. All right. So as you can see here, this is the common alkane group. So you have, if you see CH3, they're called methyl. You see H2, CH3, they call ethylene, and so on. Okay. So now it's numbering. Numbering. Okay. Let's look at this. So you need to look side by side the table that I give you, right? Especially the red table. So first is count carbon. Ignore the branch. First step, don't see the branch out things. Calculate the longest chain, the longest chain, right? So here the longest is what? 1, 2, 3, 4, 5, 6. 6 carbon. So 6 is what? 6 is what? Count the longest is hex. So prefix is 6. So count 6. Write hex first. Okay, count the longest first. This is branch. Okay. So hex. So log on the hex first, prefix. Best name is called hexane, ANE. Why? Because if you write the full formula, you can calculate is CnH2n plus 2. Right? So 1, 2, 3, 4, 5, 6, 7. Then how many H? 3 plus 2, 5, 7, 9, 12, 14, 17. Okay, 17, correct. 5, 10, 17. Okay. So here, you can refer to the table by looking at the branch. Okay, the branch. So the branch is this one. This is the branch, and you refer to the auxiliary groups. So CH2, CH3 is this one. So you copy the ETHYL. This is called, this branch out is called ETHYL. Okay. Then you need to number. You need to number from the where? So it need to count from the end of the branch. Okay, end of the branch, end of the structure, and we use the lowest number. We use the lowest number. So let's say if you count from the left, 1, 2, 3. You count from the left, the branch out is on the number 3. If you count from the right end, 1, 2, 3, 4. You use 3 first. If you count from the both end, it's always count from the end. So here you count 1, 2, 3, 4, 5, 6. Branch out in number 3 carbon. Okay, so this branch out, CH2, CH3, is branch out in carbon number 3. Right? So remember this format: sub number, sub name, and base name. Right? So the name of this alkane is 3-ethyl hexane. Start with the carbon first with its hex, and then count the CH number formula. It is under ANE. Then you look at the branch, count from the both end, count from both end. So in this case, you count from the left, will be carbon 1, carbon number 2, carbon number 3, and then branch out. You count from the right, carbon 1, carbon 2, carbon 3, carbon 4. You choose the lowest number first, and not number 4. It's not 4-ethylene, it's 3-ethylene, because you always count from the lowest number carbon. It's like playing Lego. You how you turn it, you count how many carbon it branch out. Okay, so this will be the careless mistakes in exam. Some of you will count from another side and you write this one as 4. Wrong. Always use the lowest number. Okay. So let's say they have another branch at number 4. We have 2 branch. The name will be 3, 4. 3, 4, the same ethylene hexane. If we have another branch out. Yeah. This one, you try to observe the steps. Try to observe the step. Okay, this one, you count how many carbon? How many? Count the longest chain. How many? How many? 1, 2, 3, 4, 5, 6, 7. 7 is what? 7 is what? According to table. 7 is what? Hep. Okay, hep. Then ignore the branch first. Ignore the branch first. Hep. And then count how many carbon in this structure and how many hydrogen you have. Then how to find the family first. You have saturated and unsaturated. You have 3 big family. Right? So you count by this formula, these 3 formula on the whiteboard here. Then you will know whether it's alkane, ANE, ANES, or ENES, or YNES. Okay. Then after that, you look at branch. This small branch, you look at another table. From there is a name for this one and this one. Okay. Then after that is numbering. Numbering of individual branch. For example, you have to need to count from the both end. Always use the lowest number. For example, this one, you count from the left will be 1, 2, and then 3, 4. So for the first CS3 is number 2. 2, and then the name of CS3. Comma. 1, 2, 3, 4. And then 4, the name of this one. Yeah, always use the lowest number. So I show you very fast the steps. Look at carbon. Hep. So the base name is called heptane. So this table is actually for alkane. So heptane. Then branch, you look at the table, you got 2. Right, got 2, methane and ethylene. So you have these 2. Okay. So then you need to name the position of these 2 substances. The location of substance inside the chain. Right? So you count 1, 2, 3, 4, 5, 6, 7. So this one is 2 and 4. Okay, the name of this compound is 4-ethylene. It is the first one. Sorry, 4-ethylene. Okay, so why 4 in front? Because the rules say here, list them alphabetically with hyphen. So although 2 is in front, but 2 is methane. M and E come first. That's why you put 4 ethylene and 2 methane. This is important. Huh? This is some of the careless area. Remember that you need to arrange by using alphabetical order. Yeah. Okay. Important. Huh? This one should come out in your test 2 and final exam. So this one, just observe the steps. First, count the number of carbon. So on. I think this one. So count the number. Count the number. Go for prefix table. Then look for the branch. Branch is called substance. So each one of these, you look at the shape of that one. So this one come out with CS3. CS3 is this one, methy. Then you count the longer change. Right? So you have the same one. Let's say you have the same one, same name. How you do? You have the same one, number 2 and number 4. Okay. So if they have the same substance, you just write in the numbering number 4, number 2 and number 4. Number 2, comma 4, then hyphen. Okay, so this is example for this structure. Yeah, first look at carbon. Second, most of the time it will be ANE. Of course, you use the formula to count how many carbon, how many hydrogen. Right? Most of the time it will be fall under ANE. And then look at the branches. Branches, there's a table for that one. Then you count the numbering from the end of the chain, right? You always give the lowest number first, right? If lowest number, then be careful on the substance name. You need to order according to alphabetical order, not number, alphabetical order. Right. Okay. So the rest I go very fast because it repeat the same concept. Okay. Repeat the same concept. Okay. Why does it is called unsaturated? It is because you have less hydrogen compared to saturated carbon, and this is the chemical definition. If it's alkane, ALKNENES, alkane, it means it have one double bond between the carbon. So this one saturated means you have all single bond only, one line only. You only have carbon, one line, and it form a single chain. If we have C, then suddenly C between C got double bond, it become alkane. If it's C to C is triple bond, it become alkylanes. Understand? Like for example, this one on the whiteboard. This one, CC with single bond is the unsaturated carbon, which is alkane, the first category. If I add another bonding here, it's called the second category. And I add another line to become triple bond, it become alkylanes, right? So you have a triple bond. So this is how you differentiate. So single bond, double bond, triple bond. Easy to remember. Okay. So your understanding in chapter 1 and chapter 2 on the molecular structure is important for chapter 7. You still don't know how to draw the structure, you need to do revision. Huh? If not, you're not able to answer question for chapter 7. Okay, the rest I just repeat only. I just repeat only what you understand from the previous one. Okay, this one you read. Huh? So you read. This one also you read. So you read. Huh? Okay, let's do the naming. Huh? Again, you see double bond inside the structure. It means for other second family already. Huh? We see double bond is alkane. If you see single bond, it's the first family. If you see triple bond, it's the third family. So first, same. Calculate the longest chain first. You count carbon, connect to carbon, the longest chain. You have 1, 2, 3, 4, 5. 5 is span. Right? 5 is span. Ignore the branches first. Right? You can count this one. 1, 2, 3, 4. And then this 1, 2, 3, 4. The longest is 5. Okay? You can count from here, here, and here. There are 3 possibilities. Okay? So this one is 10. So in this case, there's a tricky part. This one will be the final exam kind of things. Sometimes it's a bit tricky. You look at the structure, you might count as 1, 2, 3, 4, 5. But the longer chain is not 5, but is 6. You count from the end of the structure, right? So one combination is like this, one combination like this, and one combination from here, or here to here. So here got 1, 2, 3, 4, 5, 6. 6 is hex. Yeah, just highlight this one. You will see something like this in your test 2 and final exam. We will purposely trick you if you're not careful. Count from the longest continuous carbon chain. Hey, so this is hex, and why is hexane? Because got double bond. Yeah. Why it got hexane? Because it got double bond. And then you count branches from N. So CH3, H2C, or CH2 and CH3. So basically it's methane and ethylene, right? So this one is this one. This one, if you flip H2 to another side, is CH2 and CH3 is this one. Okay. You have two lah. You have two. Oh, see, this one also have. This one also have. This one also CH3. Okay, then you count. You count, and for double bond, just be careful. One of the exception naming alkane is to number the chain so that the double bond has the lowest number. Meaning location of the double bond is in the lowest number. Okay. So this is 1, 2, 3, 4, 5, 6. So it's number 3, the lowest number. And if you count from the other end, it's 1, 2, 3, 4. 3 also. 3 also. Right? So at the end, remember substance number, name, bond name, and base name. This structure. So you will see number first, and then the substitute name, and then the bond name and the base name. So this structure is called 3,4. 3,4 dimethyl 3-hexane. Why? If you extend this one, if you flip this one up, You flip this one up, actually, you have 2CH3. You will see this kind of question in your test too, where it's a bit tricky. You need to imagine a bit. You need to flip the carbon structure in a straight line. Okay, so this one, if you understand what I'm meaning, right? So you just flip this one here. This one will go up. So you have 3 and 4, position 3 and 4 for the methane. Because got 2, so you mention you put in di. Got 2 same. So you put in di. You got 3 means tri, Tri, right? And 3 hexane. Hexane is this one, right? Okay, so these are the some exercise. You go and see. These are the repeated example. Okay. Okay, a few more slides. This one same also. Same also. It's only this is the triple bonding. So triple bonding is actually it's a famous in final exam because it's the most complex hydrocarbon structure, right? At least you'll get one similar like this, right? So you look at the step, actually the same. This is you for your reading. For your reading. Basically hydrocarbon summarized for these slides. You burn hydrocarbon, you'll get HCO2 and water. Yeah. You burn hydrocarbon, you get CO2 and water. This one you go home and see. Okay. This one is a YouTube video, bit long. Okay. We have a breakfast. 10 minutes breaks. We continue 12:20. 10 minutes breaks. All right, then we continue. Stop here. We continue 12:20.